Okay, guys, so using what we know about multiplying decimals times decimals. So in yesterday's lesson, we actually learned how to place the decimal. We basically learned that whenever we multiply decimals, we line up the digit and not the decimals, right? So in this case, I have 0.4, or I would say 4/10 times 2/10. Now, it just so happens that if I were to line these up and stack them on top of each other, it just so happens by coincidence that they happen to line up, okay? That doesn't always happen, as we saw in this example, right? That doesn't always happen in this example, but here it does. Now, this is what's wonderful about this. We have zeros here, so that's fantastic. So what we're going to think about is, if we know that 4 times 2 is 8, we can solve 4/10 times 2/10. And think about yesterday. All we have to do is count how many places the decimal moved to the left. So if the decimal if this 2 was a whole number and it moved here, it would only move once. Same thing here. So I'm just going to count 1, 2. So that means that I have to come here to the end of my 8, pretend like it's a whole number and there's a decimal here. I'm going to move it 2 places to the left. 2 places to the left. So I'm going to go 1, 2. So I'm going to put a 0 and a 0. So that means that the answer ends up being 8 thousandths. Now, I know you're like, Ms. Knecht, that's crazy. But remember, when we multiply a decimal times a decimal, our products actually get smaller, right? Our products actually get smaller. And when we think back to this lesson, right, 2/10 times 6/10, we end up with 12 hundredths. So we could see how our product actually ends up shrinking. Same thing here, 4/10 times 7/10. Well, we know that 4 times 7 is 28, right? But in this case, it's 4/10 times 7/10, so it's 28 hundredths. So our product actually ends up getting smaller only when you multiply a decimal times a decimal, okay? And it's no different here. So what if I had 5/10 times 4/10, okay? Well, we know that 5 times 4 is 20, so I'm just going to put 20. Now I can see that the decimal has moved a total of 1, 2, 3 times. So I'm going to start at the end of 20, and I'm going to move it 3 times. 1, 2. Now I understand that there needs to be a 0 there to make it move 3. 1, 2, 3 times. And doesn't it make sense that this is 2 hundredths, even though there's a 0 there? There's 2 hundredths here. So 2 hundredths is smaller than 5/10. And think about it, if we had the grid paper, we would have shaded in 5/10 going this way and 4/10 going that way.